Welcome to Day 2, Laws of Exponents Part 2. You will need the 3 P's, paper, pencil, and patience, as well as a graphing calculator. Today we will expand on your knowledge of exponents through review and example. To start, I'd like to look at 3 different cases where the exponent is not positive for the base. In the first case, we have a base raised to the 0 power. What you should remember is that any base raised to the 0 power is equal to 1. No matter how large or small that number is, if it is raised to a 0 power, it will be equal to 1. The second case is a base raised to a negative exponent. The equivalent value will be the reciprocal of the base raised to the positive power of the exponent reflected. In other words, x raised to the negative a will be equal to 1 over x to the positive a as shown. A corollary to this occurs when we have 1 over x to the negative power. In other words, your base is in the denominator and it's raised to a negative power. Here we have 1 over x raised to the negative a. In this case, through fractional manipulation, what we end up coming out with is x over a to the 1, where the x changes positions once again in the numerator and denominator, and you're left with simply x to the a. Finally, the third case has a fraction raised to a negative power. What results here is the numerator and denominator switching places with each other, and both of the terms being raised to the positive power of the exponent reflected. This can be shown as a result of the power rule combined with our last example. So note that x and y have changed positions when they are raised to a negative a, and then they are both raised to the a power. I can see this through the power rule by rewriting x over y to the negative a, distributing this negative a to both the numerator and the denominator, and coming out with x to the negative a over y to the negative a. Now both of these, we know from our last rule, will change positions from the numerator to the denominator or the denominator to the numerator. Once again, once we switch the position, the exponent goes from negative to positive. So y to the negative a goes to the numerator and becomes y to the positive a. X to the negative a goes to the denominator and becomes x to the positive a. Now let's look at a few examples. In our examples, we are asked to write the expressions with no exponents. In example 1, we have a result of the power rule. The 0 is distributed to both the numerator and the denominator. Because of this, we should come out with x to the 0 over y to the 0. As we know from our first rule, any term raised to the 0 power is equal to 1. So this comes out to 1 over 1, or simply 1. If you have a keen eye, you can also see that it doesn't matter what is inside the parentheses at the beginning. The end result will always be 1 because the whole thing is raised to the 0 power. In example 2, we have what seems to be a power rule situation. And if we were to use it properly, you would be able to come out to the same result. However, we're going to take a little bit of a shortcut here. We can rewrite this with no negative exponents first by assuming what is inside the parentheses to be our base. In other words, 2x is going to be our base, and that is raised to the negative 3. Well, using our second rule, we can rewrite whatever is in that base raised to the negative 3rd power will be transferred as a reciprocal. So what we end up getting is 1 over whatever is that base raised to the positive power of 3. Because we know that our base is 2x, we simply write 2x into the box. Now, using our negative exponent law, we take the whole term 2x and move it to the denominator and raise it to the third power. That's essentially what we have done. We're then going to use the power law to distribute the exponent and get the resultant simplified answer 1 over 8x to the third power. Note here that I have distributed the third exponent to both terms inside the parentheses, and I come out with my simplified answer. In example 3, the negative exponent only applies to the variable x, and as such, we can rewrite this problem with that in mind. My x moves to the denominator and is simply raised to the third power. Now we use basic fractional multiplication, and I get my final answer, 3 over x to the second power. Similarly, in example 4, only the y variable has a negative exponent, and as such, only the y is going to move to the denominator. Note that I've taken the reciprocal of y and raised it to the third power, the positive power that it was raised to, which is opposite of the negative 3. Multiplying through, I should come out to x to the second power over y to the third power. In example 5, I have a negative exponent in the denominator. Remember that this simply means you move the base from the denominator to the numerator and raise it to the positive power of the exponent reflected. In this case, you simply get x to the fifth in the numerator, or simply x to the fifth. In example 6, we are working to write the answer with no denominator, because that's explicitly put into our instructions. When you see a problem as complex as example 6, I suggest that you simplify the numerator first, then simplify the denominator, and then, once you have done that, you've simplified both the numerator and the denominator, we can simplify the whole fraction itself. So once again, start with the numerator, then simplify the denominator, and once you've got both simplified, you can simplify the whole fraction together. So if I start with my numerator here, I see that I have a power law situation and can simply multiply the exponents together to get x to the sixth power. In the denominator, I don't really have anything to simplify or to change, and there are no negative exponents. So what I can say is that I'm keeping it all the same. In other words, I'm just going to rewrite it in the denominator as it belongs, in both areas, x to the third, y to the sixth, and in my final, x to the third, y to the sixth, because nothing has changed. Now that I have simplified both the top and the bottom, I'm going to simplify the whole. I see that I have like bases in both the numerator and the denominator, so I can use the division law to get the resultant x to the third over y to the sixth. Note that I've used the division law For my like bases, I subtract the exponent that's in the numerator by the exponent that's in the denominator. I keep the base. There's no y in the numerator, so the y to the sixth stays in the denominator, and I'm left with x to the third, y to the sixth as my final answer. However, we are not complete. Well, why not? Why not, you say? We've simplified everything down. Remember, what did the instructions tell us? We want no denominator. Well, how can I rewrite this with no denominator? Simply put, if I think about this in a slightly different way, I can rewrite it as x to the third y to, can you guess? Well, y to the sixth is in the denominator, so what's going to happen if it's in the numerator? That's right, it's going to be a negative. X to the third, y to the negative sixth. I can justify this idea by thinking about the problem slightly differently, which I'm going to write off to the right side here for you to see. X to the third over y to the sixth is the same thing as saying x to the third times 1 over y to the sixth. Well, what's another way of writing 1 over y to the sixth? Well, it's the same thing as saying y to the negative sixth. And obviously that will be over 1. So if I multiply those two terms together, I get x to the third, y to the negative sixth. So in order to rewrite a problem with no denominator, I will most likely have negative exponents. Next, we are going to talk about fractional exponents and their relationships to radicals. When we have a base raised to a fractional power, remember that the denominator of the power is said to be the root of the radical, which I'm noting here. In this case, x to the 1 over n shows us that n is the root. This root becomes the index number of the radical we take. In other words, the index of the radical is n. The base stays the same and is written under the radical. We rewrite this and say that x to the 1 over n is the equivalent of x to the nth root. To take a familiar example, recall that a square root has an index of 2 and is the only radical that does not have the index shown. So, a radical bar with no index assumes an index of 2. Recall also from yesterday that the number in the numerator of the fraction is the power of the base under the radical. When we rewrite from fractional exponent to a radical, the root becomes the index of the radical, and the power stays with the base under the radical as shown. So what we can say when we rewrite this is that our base, x to the m over n, is the equivalent of taking the nth root of x to the m power. Note here, once again, that the index of the radical is the root, in other words, the denominator, and the power comes along with the base under the radical. In examples 1 and 2, we are converting from fractional exponents to radical form. In example 1, we keep the base raised to the power of the numerator under the radical. The index of the radical will be the root or denominator of the fractional exponent. Thus, we see that the equivalent statement is the second or square root of x. Note that the x has remained under the radical because the base remains underneath the radical. In example 2, only y is raised to the power, so we can bring down the times 2 and deal with y alone. Y is the base and 1 in the power section. That means that y to the first will go underneath the radical, and the root of my radical will become the index, or rather the root of my fraction will become the index. So my y to the first power stays under the radical. The index of my radical becomes 3 because that's the root. and I can't simplify any further. In example 5 and 6, we need to reverse the process and rewrite the radical as a fractional exponent expression. In 5, we notice that 27, or rather 2y, is under the radical. If we consider this our base, we can say it is raised to the first power and rewrite it as such. Next, we look at the index of the radical and note that it is 5. What we can say is that the index is the same as the root of the fractional equation. So we divide the power by the index and we get my base 2y raised to the 1 divided by 5. And that turns out to be my answer. In example 6, we proceed similarly. Consider everything underneath the radical to be your base raised to the first power. Next, divide the power by the index to get 1/4 as the power outside. You now have a power rule situation and must distribute the 1/4 to all the powers inside your parentheses to get your final answer of x to the 1/2 times y to the 3/4. If you have a keen eye, once again, you will notice that the resultant answer is everything that's underneath the radical having its power divided by the index. So here, we took x squared and divided by the index 4, and we came out to x to the 2/4, or x to the 1/2. We took y to the third and divided its power by 4, and got y to the 3/4. Either way is correct. Here are the skills that you should be able to do. If you're having trouble, replay the video and focus on the skills that you're struggling with. Until next time, this is Mr. Mackman signing off.